Welcome to my project Analysis and Design of a Tall Building using ETAP software. So on the new model tab, create a new model in ETAP. The ETAP window is already open in my laptop. Use built-in setting, display unit metric SI, steel section database Indian, steel design 800 for design code, concrete design code IS 456. So let us click OK. Now it is a grid formation window. Let us keep the number of grids in X direction as 4 and Y as 4. But the spacing of grid in X direction will be 6 and Y direction that will be also 6. In the simple story data, let us make the total number of stories as 23. Typical story height will remain as 3. Bottom story height will be 3 as well. Now to get into making some typical stories, we have to do the custom story data, fill up the custom story data. Let us go ahead with that. In the custom story data, here 23 stories are already written, but the topmost 23rd story is highlighted as master story and the rest are similar to 23rd. But we intend to make it a little different. We will be doing like this, that the story 1 to 8 will be similar, then 9 to 14 will be similar, then 15 to 19 will be similar, and rest of the stories from 19 to 23 will be similar to 23. So let us make story 8 as the master story first, and rest of the underlying stories similar to story 8. I am making that as well. Now story 14 will be master story now, and from story 9 to 13 will be similar to story 14. Okay, then story 19 will be a master story again, and 18 and below will be similar to story 19. We have made that. Now story 23 is a master story that is already there, and story 20 to 22 are similar to story 23. So that are also already there. So we have made the requirement. Now let us click on OK. Grid only and OK. So the mesh will be formed now. It's taking a little time. So here is the grid mesh. It is the plan, it is the 3D view. Now let us define the material properties first. In the material property window, let us define add new material. It will be Indian, region will be Indian, material type will be concrete, standard will be Indian, the grade will be M40. Okay, we have to click OK. And OK again. So material cement concrete M40 is created. Let me tell you that all these properties, all these parameters I am selecting, these are already given to me in the project. So as per that I am selecting one. Now create another material that will be the rebar HYST 500. Okay. Now another rebar has to be created, that is mild grade, not HYST 250. So all the three materials which are required by as for this model are created. Now that we have made the field work, we are now going ahead with defining member properties for the structure. Let us first define the frame members. In the define menu under section properties, select frame sections. Here click on add new property. It will be rectangular section under concrete property. First one will be a column C500 and 500. Material will be M40. The section size will be 500 by 500. Reinforcement property, it will be longitudinal bars will be HY 500 and confining will be mile 250. Clear cover to bars 40 mm is okay. Everything else design type is column, so everything else will remain as it is. Let us click on OK. Click again on OK. So a column property 500 by 500 is okay. For the next column property, let us copy this property, add copy of property, and change the name C550 into 550, and the dimensions will be actually 550 by 550. Click OK. We don't have to change anything else because it's a column already. So another column C550 by 550 is okay. The next column C600 into 600 is again created in a similar fashion. So after creating all three columns, we now have to create another column section which is the auto select section. Our intention is that the software will auto select the column section based on the column row. We will give the properties of our preferred sections. Those are these three. So now to add one auto select column section for the program to use, click on add new property. Click on under special, click on auto select leaves. It will be column auto. The three column sections will be added and click on OK. So another column section C auto is. Now let us define the beam sections. For that, click on add new property. It is again a under concrete tab. It is again a rectangular section. Name of the section has to be given 500 by 300. Material M40. Section size 500 by 300. The rebar has to be clicked. Here we have to select design type for beam, and longitudinal bars will be HYSD 500 and mild steel for the stirrups. Cover to longitudinal bar has to be changed to 25 for the top and bottom as well. Click on OK. So everything is set. Now click on OK again. So the first beam section is created. Now in a similar fashion like the concrete column sections, we have to create other beam sections as well. Click on add copy property and change the name, change the section size, click on OK. Again add copy property, change the name, section properties, click on OK. So the three beam sections are created. Just like column, we have to create auto beam section. For that, click on add new property, click on auto select list, give a name, B auto, material design type is property, design type is concrete. Now these three sections has to be brought in and click on OK. So beam auto is created. So here all the frame sections are now created. Let us click on OK now. Now that we have done the frame section, creation of the frame sections, let us also define the slab section. Here click on add new property. Property name is, let us give it a name, slab 150. M40 will be the grade of concrete. And the thickness of slab will be 150. So we have created by clicking on OK, slab 150. So now all the sections are here. Now let us proceed with the model by drawing the members. I am selecting story 1. So this is story 1 level in the plan view. Here I have to select similar stories. Now from the draw menu, quick draw columns has been selected. From the section property, we have to select auto select column. And to draw the columns, let us select the whole view. So the columns are drawn with property, auto property. Now from quick draw beam, let us select beam property and select the whole view. So the beams are drawn as well. Now to draw the slabs, quick draw floor. Here we have to select the slab property as well. Slab is drawn on the model. I have come to story 9 to draw the next set of stories. Let us draw the columns first. Now I will be using the sidebars. Quick draw column icon to click. C auto is already selected, column auto. Now let us draw the columns as per preference. So the columns are drawn. In a similar fashion, I'll be drawing the beams now. Beams property is selected, drawing the beams. Please see that similar stories are already highlighted, so it is doing as intended. So the beams are now drawn. Similarly, the slabs. So the slabs are also drawn. Now let us come to story 15 to draw the next set of similar stories. 15, 16, 17, and 18 will be similar. Let us draw from either from the side menu or from the main menu. Draw beams to columns. Draw quick draw columns. Selected. So the columns are drawn. Now the beams are drawn. Now the slabs are drawn as well. It is story 20. Let us again draw the columns. The beams as well. The slabs. So now the model, all the elements are drawn in column. Now that all the floors are being drawn, let us move on to application of loads. I have highlighted story 8 in the plan view. Now the floor panels are being marked. So what has happened that marking the floor panels on a story between story 1 to 8 helps us to mark all the panels up to the topmost story wherever applicable. So all the floor panels are being marked, selected. Now let us assign shell loads over this uniformly. It will be dead load and the dead load magnitude is 2 kilonewton per meter square. It's a gravity load, so acting downward. Click on apply and then OK. So 2 kilonewton per meter square dead load is being applied over all the panels of the entire building. Now let us define the live loads. For that, because there are similar group of slabs or stories are there. So starting from the bottom, we have to take story 8, 1 to 8 first. Let us select similar floor stories. Now highlighting all the floor panels, we select all the panels between story 1 to story 8. Now going to shell loads, uniform. Type of load will be live and at the bottom it will be 5 kilonewton per meter square here. Let us select now story 9 and similar stories being highlighted. All the floor panels are selected and assigned a cell load of live load of 4.5 kilonewton. Now going to story 15, because that is the starting of another set of similar stories. At story 15, let us select all the floor panels, similar stories being highlighted, and live load being defined on it as 4 kilonewton. Let us now move to story 19. I think it is story 20, because that is the starting of the last set of similar stories. Highlighting the floor panels while similar story is being selected, let us assign the cell load of 3.5 kilonewton live load. So we have defined the date and live loads. Now let us define the wall loads. First, let us go to story 1 again. Now select the peripheral beams while similar stories being highlighted. All the peripheral beams from story 1 to story 8 are being selected. Let us assign a frame load, distributed frame load of dead load type of 0.2 kilonewton per running meter. Apply and so I think one number is missing. Let us keep that as well. Okay. Now let us select another story between 9 to 14. The similar stories being selected. The peripheral beings highlighted to being subjected to loads. Now let us assign a frame load distributed of 0.2 kilonewton per meter. It is also frame load. So it is being applied. Now let us go to next story, story 15. That is the next set, 15 to 19. The peripheral beams are highlighted again. We have to be very cautious while selecting the beams. Now assign the frame loads of 0.22 km. Now select the story above the last. To select the last set of similar stories, select the story above story 19. I think that is story 20 onwards. Peripheral beams are being selected while highlighting the Odd story option has to be highlighted. Similar story option has to be highlighted. So assign frame load distributed authority. Now that cell load, cladding cell load is been assigned to the whole of the building, we have to remove the cladding load from the topmost floor, as that is the roof of the building. So let us go to line 23, story 23, and then select the outer periphery members of that particular story. All the members are selected, 6 frames in total. Now to remove the load, go to assign. Now to remove the load, go to assign frame load distributed. This point 2 has to be removed. So let us choose delete existing load, apply, and OK. So the topmost cladding load, topmost floor is removed. Highlight the base story. With one story being highlighted, select all the base joints and assign them under a joint and restraint as fixed joint. Now under auto draw cladding using those draw. Now after assigning all the gate and live loads, it is time for us to define and assign window. To do that, first of all, let us define window. Load pattern, I must say. Under the tab load, we have to make wind load. Type of load will be wind. The code as per which the load will be calculated, that is Indian IS 875. Now we have to create the load. So wind load is created. Now to define additional parameters, let us modify the lateral load. We are working with a model for Bangalore region. So for Bangalore, as per I8 875 part 3, from the map view, we can get the basic wind speed, which is 33 meter per second. As per 11th clause of part 3, IS 875, terrain category for Bangalore will be 3. Since the structure is of 69 meter height, the class of structure will be C, it being more than 50 meter, the dimension being more than 50 meter list. That is dimension. Risk coefficient, as already been discussed, for this type of structure, it will be 1. For Bangalore, the topographic factor, since the windward slope is less than 3 dB, the topographic factor will be 1 as well. So let us click OK now, and the load is created. Fine. OK again. So this is the wind load being defined. Now this wind load has to be assigned on different faces of the building, the cladding faces of the building. For that, let us see the elevation, different elevations on which the load has to be applied. Now, at row A, selecting all stories, and B, again selecting all stories, we have to assign the cell load as wind pressure coefficient. This pressure coefficient is the external pressure coefficient CP as per the relevant clause of Part 3 of Wind Code IS 875 for a building of 18 meter by 18 meter land dimension and 69 meter height. The CP value for the windward side will be plus 0.8. So we are applying that load on those spaces. Let us see, on row B it is been applied, and on row A as well. Now for row C and row D, this is the row C. While selecting all stories, let us select the exposed external surfaces. For D as well, let us assign the wind loads. The wind pressure coefficient, this will be the leeward side, and the wind pressure coefficient will be as per the same clause of IS 875 part 3 for the building, the defined building dimensions. It can be seen that the same will be minus 0.25. So we are applying that load on those spaces. So this is elevation view B, and this is elevation view C. If we take the plan view, we can see that loads are being defined in the windward and leeward side as well. Now for the sideward wind, let us take elevation 1, and while highlighting all stories, let us select the external surfaces. Then for elevation 2 as well, select the external surfaces. Then for elevation 3, the external surfaces. We are doing this because on the sidewards, both side coefficients are same. For row 4, the external surfaces are all 4 rows have been examined and the external peripheral surfaces are highlighted. Now we are assigning the respective wind load, wind pressure coefficient, that is minus 0.8 as per the same clause with same parameters of the building, and it will be leeward or sideward. So okay, we have defined all the wind loads. Now let us examine in the plan view as well. Like for the story 7, we can see that all the horizontal loads are now defined. Now that we have applied all the loads over the already defined model in which the member sections are given. Now we are going ahead to analyze the model and then carry out design on the same. Now from the analyze menu, we are clicking on the run analysis. So it has started analyzing the model. It will take some time because it is a big model. So after analysis, the displacement values are being given. Now let us carry out design check on the frame, on the building. So it has started checking the design of individual elements, beams, columns, and then slabs. It will take a good deal of effort, I mean machine effort, to complete the design. So it's a complicated model that needs good amount of computer resource. So let us wait till the design check is complete. Now that the first round of analysis and design being carried out, uh, ETAP software is highlighting a message that analysis and design sections differ for 705 numbers of concrete frames. So do you want to reiterate analysis and design? So what this means? This means that as I have already told that we are giving beam and column sections auto select property. As per that, the software first tried to check all frame members with the minimum auto selected section, that is for column 500 by 500 and for beam 500 by 300. But for this 705 number of concrete frames, it is observed that the sections cannot take the induced load with the minimum cross section. So the next one size higher cross section is required as per the auto select option. So in this case we have to click on yes so that the software can select one size higher member for these frames, for these elements. So I am clicking on yes. The analysis and design being reiterated. Now the design check will be carried out. Okay. Now the iteration round, rechecking of the members with one size higher section is being completed by ECAP, and there is no more message of mismatch. So all the sections are being designed. Now to proceed further, after the design being completed, we have to see the reinforcement detailing of individual elements. However, in the latest version of CSI ETAPS, the detailing part is being separated into a separate module, a separate software. So I am referring to the CSI detail for rest of the parts. Here CSI detail here. So this is CSI detail is being loaded. Now we can very well close ETAB ultimate. It will be ultimately opened from the CSI detail itself. Here we are finding that model that has that file that is being generated by ETAB software. So that file I am importing it now into CSI detail. ETAB is being opened automatically. Now a dialog stating the import will happen. Here data extraction is being carried out. Let us wait a little bit. Okay, now CSI detail needs to load the file, the model. It is loading. Here we are. The complete model is now being loaded into CSI detail. We can check individual members like beam schedules. The reinforcement of beams are being given. Longitudinal bars. Now these are the speed ups of different beams at different floor level. This is a beam Mark 1 at 23rd floor, like this. So we can see that the complete design, analysis, design and detailing of the tall building model is being carried out with the help of ETABS software, and later on it is being imported into ETAB from ETAB into CSI detail. And with this, I am concluding my project of the tall building analysis and design. So, thank you very much for listening. Good day.